Hi everyone, this is Team2 from ISDS 570. We are going to talk about the stock market forecast. So I will talk about the introduction. Amy will discuss briefly introduce SP 500 and the data set. How do we choose the data set and the features? Mark will talk about the strategy and the methods. Also the analysis and observation. Amy will finish the presentation discussing findings and future scope. So, what is stock market forecasting? It is to use appropriate tool, method, and data to make prediction on the future stock events. So, one of the benefits can be business makers make appropriate decision based on the result if the prediction is accurate or close to accurate. And one of the risks can be sometimes the prediction is not accurate due to some unexpected events, such as the COVID-19 pandemic in 2019. The economic was shocked heavily due to the pandemic. In this situation, the stock event is hard to predict. So our project will use time series and PG SQL, RStudio to and randomly selected 15 stock data to make forecast and use SP500 as a standard to evaluate the forecasting performance. What are the S&P 500 stocks? So based on the Wikipedia definition, it is a Standard & Poor's 500, a free float weighted measurement stock market index of 500 of the largest companies listed on stock exchanges in the United States. It is one of the most commonly followed equity indices. So we choose 2013 to 2017 data from Yahoo Finance, and we use S&P 500 stocks as a standard to evaluate the performance of our prediction. Next, Amy will discuss the stocks selected from the custom portfolio.
Thanks, Ted, for the brief introduction. I will talk about stock ticker selection here. In our project, we have selected 3 tickers for each group member. It is selected randomly and it is based on first letter of last initial of each team member. In total, 12 tickers were selected. Here, 4 selected tickers belongs to NYSE index and it belongs to NASDAQ index. Now we will talk about dataset, its features, and the tools we have used in our project. First of all, we have extracted data from ConvilleWiki. It has 5 years of NASDAQ and NYSE data from 2012 December to March 2018. Our training period for the portfolio model is from 2013 January to December 2017. Further, we will test and compare our returns with the 2018 January to March 2018 data, and we will see how our portfolio performed and is used for the backtesting. For data accuracy, we excluded tickers that have more than 1% of missing data. Now, for all the process we have done, we have used various tools. for maintaining and forecasting our data as well as pre-processing it. So here, various tools used are Excel, R, and PostgreSQL. So we'll talk about it now. For Excel, we used it for creating a custom calendar with the help of an extend function called networkdays.intl. PostgreSQL, it's an open source relational database management system, and we used it to load and prepare our data set with the needed parameters and adjustments for our project. Further, we used our programming to write and run the code for portfolio optimization. We imported our clean dataset from PostgreSQL to R and created Portfolio to calculate the annual returns. Various packages were used during this process. Some of them are like Reshape2Zoo and Portfolio Analytics. Now, further, Mark will talk about methods and strategy used in portfolio optimization.
To prepare our dataset, we use the following tools listed here. The bulk of our data prep and transformation was prepared in SQL using Postgres. We then transformed the data in R using the Reshape2 and Zoo packages in R. And finally, we analyze and optimize our portfolio using the performance analytics and ROI packages in RStudio. The first steps were to update the datasets in SQL by adjusting the date range in the QuandaWiki file. Extract and merge the SP500 TR data obtained from Yahoo Finance, and fill in the custom calendar to include all of 2018 trading holidays. We selected only tickers that had less than 1% missing data from 2013 to March 27, 2018. Within this date range, we chose to cap the daily return at 10 times the SP500. Therefore, any ticker with a daily return greater than 40% was excluded from our pool for selection. We calculated the daily returns from the remaining tickers in SQL and extracted only the data within our specified date in R. Majority of the tickers contain only 2 missing values, with a few containing more than 4. We use the Zoo package in R to fill any missing data with the last observation up to a max of 3. Finally, we withheld all data from 2018, which is 59 trading days, to be used for training and obtain our portfolio weights. The daily returns for our 12 random tickers were randomly selected using the first letter of our last name. This is the cumulative return from 2013 to 2017 of our 12 tickers and the SP500 TR. We can see that there are 6 tickers trending below the SP500, while we have 6 tickers above the SP500. Each individual ticker has a lower Sharpe value and a higher standard deviation than the SP500, which is typical of an individual stock.
Thanks, Mark. Hi, I'm Antri Sujon. Now let us look into some returns and optimized weights. We've extracted the weights from our optimized portfolio. These are percentages of the portfolio that concentrate within particular tickers. Therefore, if a ticker has a higher weight, it means that it'll impact the portfolio more. We can see here that JBT, TMO, and ZBH hold about 29, 18, and 24% weights in the portfolio. Companies such as Johnson Outdoors and La-Z-Boy Incorporated have a negative weight assignment, means that these stocks negatively impact the portfolio. When we look at returns, we've compared the annualized and cumulative returns between the SP500 TR and our portfolio. We can see that our portfolio has a lower standard deviation and higher returns, both cumulative and annualized. SP500 TR also has negative returns, which is likely a higher investment risk. Now let's summarize some of the findings of this project. On the right, there is a chart which compares the cumulative returns between SP500 TR and our portfolio for the date range of Jan to March 2018. Our portfolio has a similar trend like SP500 TR, but has higher annualized and cumulative returns. Our cumulative returns are 1.9% higher than SP500 TR. Our standard deviation is 1.62% lower than SP500 TR, indicating that our portfolio has higher stability and is less volatile. The Sharpe ratio measures the performance of a stock when compared to a risk-free asset after adjusting for its risk. The best Sharpe ratio is 1 or higher. Even though our Sharpe ratio is not greater than 1, it is still better than SP Finder TR, which is a negative value. Overall, I think our portfolio is likely to give better returns than SP Finder TR with less risk. Lastly, looking into the future scope of this project, stock market prediction is not very simple, and there are multiple factors that affect it, such as politics, natural man-made disasters like the recent COVID pandemic, economic factors, foreign markets, interest rates, etc. Therefore, using new methodologies such as artificial neural networks, artificial intelligence, machine learning, etc., we can formulate better predictive analysis of the historic data. Also, in the field of ETL, I think the future is going to migrate towards data management frameworks for big data rather than not only data integration. This will probably include solutions for data security, data quality, data governance, etc. Thank you. Hope you enjoyed our presentation.